Paging. Divide physical memory into fixed size blocks called as frames. Keep track of all the free frames. Divide logical memory into blocks of same sizes called as pages. To run a program of size n pages, need to find n free frames. Set up a page table to translate logical to a physical address. Remove or reduce external fragmentation. Internal fragmentation exists. So look at this diagram. In this diagram there are three elements: logical memory, page table and physical memory. Logical memory is divided into pages which are of same size. Physical memory is also divided into fixed sized of blocks termed as frames. So here in the third element, that is physical memory, the diagram has certain page numbers represented, that is page 0, page 2, page 1, page 3, all these are pages which comes under logical memory. Then frames are allocated with frame number 0 to 7, so total 8 frames are existing in this physical memory, and a page table for the translation of logical to the physical address. Totally there are 4 pages, 0, 1, 2, 3. So 0, 1, 2, 3 are nothing but, here in the page table diagram, these are nothing but page numbers. These page numbers are represented here in page table. And what are the frames allocated? So there are several frames here in the physical memory. Some frames are allocated to these pages, that is 0, 1, 2, 3, page 0, page 1, page 2, page 3 are allocated in some of the frames. That frame number is referred here in the page table. For example, for page 0 it is frame 1, for page 2 frame 3, for page 3 frame 7, and for page 1 it is frame 4. So this is how the pages are allocated to the frame numbers. Next concept, address translation. This is the same similar way of representing, but a diagrammatic representation, how the data is transmitted from the CPU to the physical memory through the page table, logical address as well as physical address. So logical address, I told you, it is composed of pages here, fixed sized pages, whereas physical addresses are made up of fixed sized frames of same blocks. So in this page table, frames exist as well as pages, that is page numbers exist. All these are mapped together here in the page table, and finally the data is stored into the physical memory. So how this logical address and physical address function? So logical address, in this P is nothing but the page numbers, D is nothing but the address part, whereas physical address here also D is nothing but the address part, F is nothing but the frames. So this with the address, frames with the address, how it is linked and finally stored in the physical memory from the CPU. So how it is stored in the physical memory, that is explained in this particular diagram, address translation. Next, free frames, allocation of free frames. Certain pages are stored in backing store and some of the frames are free here. Free frame list 14, 13, 12, 18, 20, 15, all these are free frame lists. And pages 0, 1, 2, 3, and these are nothing but the new processes. Now here there are blocks of the physical memory, and here these are nothing but the frame numbers. It is beginning from 13 to 21 here, and you can see the difference in the color here. Some are in violet color and some in light blue shade, but all the frames are empty here. This is before allocation diagram. So here after allocation, one of the frame is left here, left out behind, that is 15. So page 0 to 3, there are total 4 pages, and here 13 is occupied by page 1, and 0 is occupied by page 14, 18 is occupied by page 2, and 3 is occupied by page 3 is occupied by the frame 20. Page 2 is occupied by frame 18, So these are nothing but frame numbers now. These are the pages allocated to this particular frames. So 0, 1, 2, 3 are nothing but the page table. This is the page table diagram here. These are nothing but the page numbers, and which to which frame these pages are allocated. Those frames are numbered here. So one of the frame is left free here, that is the 15th frame, so which is not occupied. This particular frame is free. Here there are frames, but whichever is indicated in blue color, actually those are occupied by the processes. Because look at this diagram here, backing store. In this diagram, after this particular box where it has page 0, 1, 2, 3, the outer part of this is nothing but the process. So it means this blue color is for the processes. So new processes is occupied here, and pages are occupied in these places. So here total 5 blocks are free for the pages to occupy. Out of that, because in the list we have total 4 pages, only 4 can be occupied. So one is empty here, that is the 15th one. No page is occupied here because only these 4 pages exist. So this 15th frame is free, so that 15th frame will be in the free frame list.